Welcome to Mission APSC AZ YouTube channel. Today we are going to discuss one of the important subject of civil engineering, that is reinforcement cement concrete structures. And in this video, I'll cover up various design methods which is required for designing RCC structures. So this subject have around 6 to 7 marks, which is in assistant engineer, junior engineer, as well as any kind of competitive exam, particularly in the branch of civil engineering. So today we'll discuss about various design methods. Before discussing the RCC, we have to know about the term which is related to RCC. So if you pronounce RCC, then we have reinforced cement and concrete. So if you see concrete is nothing but all people we are familiar with that concrete is nothing but it is a mixture of sand, you can say mixture of aggregate, and you can say cement with a certain proportion of water. So যেতিয়া আমি water লগত sand, aggregate and cement mix up কৰো, then we get concrete. So we can say concrete is not a homogeneous mixes, it is a heterogeneous mixes. Why we say it is a heterogeneous mixes? Because when we go to any construction site and we see the concrete, some of the part of structures have reduced in, you can say, aggregate or gavels. Some of the part of that particular structure which is reduced in sand, and some of the part of that particular structures is reduced in cement. That means there is no uniformity in the concrete mix-up. So কিছুমান জায়গাত আমি বেছিকে sand পাওঁ, কিছুমান জায়গাত আমি বেছিকে বালি পাওঁ, কিছুমান জায়গাত আমি বেছিকে aggregate পাওঁ. That means বহুতখিনি boulders এটা জায়গাত কেতিয়াবা isolated হৈ যায় when we mix up the concrete, আৰু কিছুমান জায়গাত only cement particles বিলাক বেছিকে পোৱা যায়. We can say পুৰা smooth plastering য'ত দেখা পাওঁ তাতে sometimes cement কিছুমান aggregate cement কিছুমান কি হয় তাতে mix up বেছিকে হৈ থাকে. So we can say concrete is a heterogeneous mixes. We have two types of mixers, one is heterogeneous and another is homogeneous mixers. For imaginations, homogeneous mixers, you can say, suppose in biscuit, when we try to break that biscuit, we have several components of biscuit, and in every components of that particular biscuit has same taste, or you can say same property. And we cannot segregate from that particular biscuit its ingredients. So tar ingredients bilak tumi separate korbo nwara. You cannot separate the sugar from that particular biscuit, or you cannot separate that ingredient from that particular biscuit. That's why we can say it is a homogeneous mixes. But concrete, we can separate. Once when we break concrete, we can separate the aggregate, we can separate the sand particles. Okay, so that's why we can consider concrete as a homogeneous mixes. So if you see one of the properties of concrete, that is all of you know that it is good in compression but weak in tension. That means suppose this is my beam, eto mor eta beam hoy. In that particular beam I am putting some of the external UDL. So once the load is coming in that particular beam, what will happen if we consider this particular axis as a neutral fiber? When we draw the diagram in lengthwise, the midpoint or the midline is known as neutral fiber. Aru jodi ami cross section draw koru, then we can say it is a neutral axis. So a neutral fiber or upor portion to ki hoy, because of this loading, it's try to compress. If you see this figure, so upper part to compress hoy like that. If hale compression hoise, that means your length to komi goise. But similar way, but your jitu taller part, the lower part of the beam, that get elongate, because upper part to jodi compression hoy, obviously in the lower part it get elongated. That's why in upper part, this particular beam, the concrete suffers compression, right? And in the lower part of that particular beam, the concrete suffers tension. We know that concrete is not a ductile material, it is a brittle material. Brittle means it is ductility or ductility is very less. Ductility less means we cannot extend or we cannot expand this particular concrete. If we try to expand uh, that concrete will be break. That means it is very low in tension and it is a high brittle material. But if you compare any other type of material, like if you compare with silver, in silver, if you give some tension force, that is if you try to pull that particular silver material, it will expand, or it has you can say it has high value of tension, it can take high value of tension. But in concrete, since it is a brittle material, once when there is a tension forces coming, it's the crack is occurs in the lower part, so he cracks to lower part of develop hoy. That's why to overcome that particular failure or to overcome these cracks, what we can do, we can put some of the ductile material in the lower part of the beam, and that ductile materials which we put inside the concrete, that is called reinforcement, or it is called reinforcement. So to overcome the tension force, we additionally put some of the ductile material like silver, we can put gold, we can put copper, we can also put steel also here, and that particular wire is nothing but we can say reinforcement. Now question arises, আমি কোনটো material use কৰিম? Will we go for gold, because gold also have high ductile properties or ductility is more. Similarly, if you see copper also have high ductility values, still also high ductility values. Silver is also ductile material. So out of these 4 or 5 combinations, we are going with steels. So some of the reason behind why we choice steel is that because gold, copper and silvers, they have not economical point of view, they are not economical. If you see the cost of gold, copper, silver, these are little bit higher as compared to steel. And another reason behind is that once when the beam is subjected to some thermal stress or some temperature difference, the concrete material will try to expand or try to sink based on temperature increment, right? But if we put some of the material in the lower part of the beam, that is if you put copper or if you put gold in the lower part of the beam, once when the temperature is rises, the expansion due to that particular temperature for concrete and for that gold material or for that copper material is not same, because their coefficient of thermal expansion, which we can say sigma c, or we can say alpha c, or for concrete, or we can define alpha steel for steel, or we can define alpha gold, alpha z for gold, right? So যেটো thermal expansion or coefficient hoy, that coefficient is different as compared to concrete for gold or for copper, for silver. But if you see the coefficient of thermal expansion for concrete and steel, this is nearly same. That's why we are choosing steel as a reinforcement material as compared to gold, copper or silver, only just because it is economical. And another point is that the coefficient of thermal expansion is also similar, or you can say almost same as compared to concrete. That's why once there is an increment of temperature or decrement of temperature, the concrete as well as steel members equally expand or shrink. If it is not there, then obviously there will be cracks occurs. That's why we are choosing steel materials. Okay. Next part is if you see simple bending moment equation, that is m by I is equal to sigma by y. Sigma is nothing but it is the stress developed in the beam, and this sigma is nothing but it is equal to the moment divided by moment of inertia into the y, that is the distance from the neutral axis to the you can say extreme fiber. So a particular equation to সহায়ত we can try to calculate the values of, you can say, sigma or stress in that particular members. Next, you can say we have several methods to design RCC structures. So our main point is we have to know about various methods. With the help of those methods, we can determine the working. We can determine the you can say design of an particular RCC structures. So first method, we're going to discuss about working stress method. So in working stress methods, what we can do, I have taken some random values. Suppose আমি কি কৰিছো, we are consider one particular column. Etu eta amar column ase. In that column we have 1000 kilonewton load is coming. So he column tut from the slab or from the structures 1000 kilonewton ahi ase a particular beam tut. So ami janu, what we know that stress is nothing but external load divided by, you can say, area. So area is nothing but external load divided by sigma, and where you can say external load is 1000. And if you plot the graph between, you can say, stress versus strain, and we can suppose we are getting one particular graph like that. Okay, so here see, if we consider sigma, that is stress, or you can say stress of that concrete, if we consider as 20 kilonewton per meter square, then we can calculate the value of area. That means what is the area required for that particular column if it is 1000 kilonewton load is coming and that particular concrete is able to bear a strength of 20 kilonewton per meter square. Tetia ami pam area is 50 meter square. So now my point is that ami working stress method we are consider the lowest, or we can say lowest possible stress. Ami jitu stress ami determine koribo jao ba ami jitu stress design not consider koru hetu low hoy, that is 20 kilonewton per meter square. If you see the graph, you can say the concrete can bear up to this point, but the maximum stress is generated here, but we consider only 20 kilonewton per meter square. This graph I have done randomly for your understanding purpose. So here you can see in x-axis we have strain, x-axis ot amar ase strain, and in y-axis we have, you can say, stress. So ami hodai x-axis ot strain lobo logia hoy because strain is fastly generated as compared to stress. So prothomote jetia loading ahibo, loading ohar loge loge dimensions bilak change hobo, that means strain change hobo, aru strain change hoar pisot he stress change hoy. He karone ami x axis ot, that is means hodai ami graph bilak ki koru, y is nothing but a function of x, so hodai ami x or function ot loi pelai determine koru. That's why we can consider strain in x axis and stress in y axis. So here we consider sigma is 20 kilonewton per meter square, a arbitrary value we are considering, which is a little bit lower, or you can say lower as compared to the highest value of the stress, and we see that area is 50 meters square. So enake jodi ami design koru, if we going to design in this way, we have seen that we can design the area is large. Ami jitu area palu he area to bahut large palu, so I can say it is a uneconomical design methods, because ami larger area provide koribo logia hoise, that means larger sections we can provide. Ami land breadth with ebilak dangor ke lobo logia hoise ba huge lobo logia hoise. But main kotha ki jeto ami yare concrete stress tut ke bahut tolot ami loisu higher value ke, that means our area is, you can say, more and our stress is, you can say, less. That's why ultimately ami bahut dangor ke, you can say, at a huge column, bahut dangor eta column banaisu, that means member is obviously stable hobo aru safe hobo, because here jitu failure load, you can say extreme load ot ke ami bahut komot design to korisu, he karone etu koa hol working stress method. So working stress method or main point hoise ki we can have uneconomical larger sections, and second is members are stable and safe because we give additional area. Okay, we give more number of land, more number of breadth as required. okay. So that means 1000 otke uporot jodi bahut kilonewton ahe 5000 6000 তেতিয়াও এই পার্টিকুলার মেম্বারটোৱে সেই লোডটো বিয়াৰ কৰিব পাৰিব বাট মেইন কথা হৈছে এইটো ইকনমিক্যাল নহয় সেকশনস বিলাক আমি বহুত ডাঙৰকে দিবলগীয়া হৈছে ৰাইট সো সেই কাৰণে হেটো ওভাৰকাম কৰিবলৈ আৰু এটা মেথড আহিলে দ্যাট ইজ কল আল্টিমেট লোড মেথড সো নেম ইটসেলফ কল আল্টিমেট লোড মেথড আগতে যদি আমি স্ট্ৰেছৰ ভ্যালুটো লোৱাৰ পইণ্টত লৈছো নাও উইল টেকিং দ্য স্ট্ৰেছ ভ্যালু ইন আপাৰ পইণ্ট সো আপাৰ পইণ্টত সাপোজ আই এম এজুমিং 50 kilonewton per meter square. And if it is stress is 50 kilonewton per meter square and area will be how much? External load is 1000 and sigma is 50. So ultimately we get area 20 meter square. Or yet actually area 50 meter square. Now if we provide 20 meter square then also it will withstand. But it ki extreme case or karone hoy. Suppose আমি এতিয়া যেটো beam ultimate load method order যেটো কলম ডিজাইন কৰিম তাৰ লেন্থ ব্ৰেথ তো বহুত সৰু হ'ব that means আমি এটা স্লেন্ডাৰ মেম্বাৰছৰ কাৰণে স্লেন্ডাৰ মেম্বাৰছ এটা প্ৰভাইড কৰিম মানে এক্সট্ৰিম কেছটো চাই পেলাই আমি কৰিছো হেতু কয় আল্টিমেট লোড মেথড বিকজ আমি ডিজাইনটো কি কৰিছো আল্টিমেট ফেইলিয়াৰ পইণ্টৰ ওচৰত যেটো ষ্ট্ৰেছ হয় সেই ষ্ট্ৰেছটো লৈ কনসিডাৰ কৰিছো যেহেতু আমি ষ্ট্ৰেছৰ ভ্যালুটো বেছি লৈছো দ্যাটস why since area is inversely proportional to stress so I can get area amount is less as compared to others so what we can note from this particular diagram or this method that is cheaper sections are obtained hetue bahut slender or you can say slender members tumi obtain koribo para where length breadth height eblak kom holeo hoy that means amar khorsa to kom hobo hekarne etu koise cheaper sections but what is the disadvantage members are unstable and unsafe jeto ami limiting condition ot loi asu if you put some additional amount of load suppose beam to kiba karonot because of earthquake or some other loading what will happen the beam loading will increase 1000 to 1100 kilonewton then it will obviously unstable because ami extreme point to loi pelai design koisilo so he karone ami likhisu members are unstable and unsafe and third to ma koisilo cylinders members are estimated is one amar horu size or cylinder wire type or you can say members ami estimate koribo paru so hei duita method or bahut kini disadvantage ase kisuman advantage ase yate main advantage to hoise ultimate load method or cheaper section aru agor to jitu working method asile tate advantage to asile ki it is stable beam to jiman load ahilo generally this particular column will not fail if we design in working stress method so hey duta method combine kori some of the researchers they made another method that is called limit stress method হেতু আজিকালি আমি ওয়াইডলি ফলো কৰো আৰু এটো IS 456 2000 যেখন আমাৰ ইন্ডিয়ান স্ট্যান্ডার্ড IS কোড হয় হে কোডখনতে এই পার্টিকুলার মেথডটো ইউজ কৰিছে সো ইয়াতে কি কৰিছো আমি না কি হাই পইণ্টত লৈছো দ্যাট ইজ 50 কিলোনিউটন পাৰ মিটাৰ স্কয়াৰ স্টেজটো লৈছো না একেবাৰে লোৱেষ্ট পইণ্টত লৈছো সাপোজ 20 কিলোনিউটন পাৰ মিটাৰ স্কয়াৰ আমি লৈছো হে দুটা আমি লোৱা নাই উই আৰ টেকিং ইন বিটুইন working stress or ultimate load method jiman stress loisilo or you can say working stress method jiman stress loisilo tar major eta value loisu so hetu ki basis ot lom keneke lom he gutei khini ami next class ot discuss korim now for the time being so you just remember in limit stress method we are taking stress value in between working stress method and ultimate load methods so ultimately আমি sigma to jodi 30 kilonewton per meter square kori do then area will be amar load aisile 1000 aru sigma to amar kiman 30 so ultimately ami area to palu 33.30 meter square prothom kistu ami area paisilo around 50 meter square right and pisor to ami paisilo 20 meter square or now so 33.30 mane etia ami jibilak members design korim heblak iman besi huge no hoy ba iman besi slender no hoy but iman besi horu no hoy so that's why it is a intermediate okay that's why we can consider it is economical aro since we are not consider the extreme point we are not consider the lowest point so it will be members are we can say safe and stable okay so members bila amar safe hol stable hol so gute duita point ami overcome koribo paru jodi ami eta intermediate stress consider koru so hegita asle basic difference between limit state method ultimate load methods and working stress method this is a main difference so moi just randomly some figures to so these are not as per scale or you can say as per their actual behaviors just for your understanding purpose I have drawn 3 type of such graph, and I have also tried to explain the basics of some of the methods, that is limit state method, working state method, as well as ultimate loop method. And আমি limit state methods design কৰো generally in case of RCC. so হেখিনি আছিল আজিৰ ভিডিওটো। যদি তোমালোকে ভিডিওটো চাই উপকৃত হোৱা বুলি ভাবা দেন চেনেলটো সাবস্ক্ৰাইব কৰি দিবা। থ্যাংক ইউ ফৰ ওয়াচিং।